Hello, my name is Kathan Shukla, and I'll give you the presentation for the recent project that I've done. It is on the real-time event handling and signaling. So, uh, if you want to like interface an input device, let's say a mouse, and you want to detect an right click, left click, if the right click is like pressed or release, then you can use this file system node for that. And it is a character device, so it basically supports the read operations. So you can use the input event structure from this file. And this input event has uh, this elements type, code and value. So using this elements you can detect if it is a right click pressed or right click released, or left click press or release, or any movement other than that. So if I want to detect a double right click, then what I will do, I'll wait for one right click, then I'll start a timer, and then on the detection of the consecutive right click, I will compare the time stamp, and then I will decide if I want to reset a timer or detect a double right click. So now how signal handling works. So basically I'll just this is the handler function, and this is a uh, sig action structure. So in the as a handler element of this structure, I will give the pointer to my function, and then I'll register this sig action for this signal. So if I want to raise a signal, I want to um, send a signal to one thread. How can I send it? I'll use pthread kill. Now, what is imprecise computing? In real-time systems, approximation is uh, is a good in case is better than no output. Sometimes the process may take more time to finish. So, and we have time constraints in our real-time system. So, it is better to have approximate output. So, I can save the context by using this side jump, and I can do a long jump from, and I can do a long jump from anywhere in my program. So uh, if this is the return value of the long jump, so if we check the return value of side jump, we can achieve asynchronous transfer control. So basically this long jump call will transfer or program execution to the side jump, but the return value of the side jump will be this whatever we pass. So we can check the return value. uh, Now, so how this works in my case is uh, yeah. So here I am computing this geometric series. So this is my computation, and when I do a long jump, I want my computation to terminate. So when it is set jump, it will return 0, but when it is coming from long jump, I am returning some -1. Yes, so it will not go into this loop, and then it will print the sum whatever it is. So this is imprecise computing. Now, how can I assign priority to threads? First of all, I need to set a scheduling policy. So these are just some basic APIs that we can use. Um, and Yeah, this is for setting the priority. And yes, if we set the policy and if we set the priority alone, it does not help. We need to set the thread does not inherit the scheduling policy and priority of the parent thread. So we can use this APIs uh, to assign the thread priority before the creation of the thread. Also, we can also assign the priority and policy after the thread creation. Uh, this is like the kernel shark can be used to analyze the execution sequence of the threads and processes. So we can do we can use a trace command, and we can record signals, functions, and almost everything by using that. It will generate a .dat file, and that we can open using kernel shark. Uh, so these are the tasks given to me as an assignment. So um, when what will be the execution sequence when a thread receives signal when it is running or runnable. So the procedure is I am running an high priority thread, and I'll send a signal to a low priority thread. Now for this I need to uh, like our CPUs are multi-cores. So for this assignment, I needed to set my configuration to run all the programs on single core. So the outcome that I got was that the signal was delivered as soon as it is generated. You can see here that the signal is generated here on the different CPU for this when another thread was running. So this was the case for that condition. When I run my program on all CPUs, the signal is generated and delivered instantly almost, and then this is the case when I run my code on this single CPU. So the signal is, in this case also, the signal is generated and it is delivered in very less time. So uh, the task another task was that to detect an execution sequences when the receiving thread was sleeping or doing system call. So in this program I I created a thread that registered signal handler and performed a system call or sleeps, and I sent a signal using pthread kill from main thread to the thread. Now the outcome was when in this case also the signal was delivered in very short time after being generated. So and the task 3 of my assignment was was to in yeah. So in Linux, signal is delivered arbitrarily to one of the threads, or one of the threads that has registered the signal handler. So if for this is for the case of SIG-IO signal. So I if I wish to deliver the SIG-IO signal to all the threads that have registered the signal handler. So how can I do this? In this the provided solution, mm, I am using a SIG user 1 signal, and this I'll register a SIG-IO handler for my main thread. So this handler for SIG-IO will trigger a SIG user signal for all the registered threads. So in the end, all the signal user one handler function will get called for all the threads. The conclusion for this assignment is um, signal is delivered fastest when it is the catching thread is already running, and the latency is very low, but it takes more time if we compare to the fastest case when it is running in a single processor, and the thread is runnable. So the program is running in a single processor and the thread is runnable. So basically the processor is executing high priority tasks. So the time consumed for switching from high priority to low priority, it takes time.